Okay, so you random integral 4 that you sent me, so you were given the following expression, and it was the rate of change of temperature with respect to time is equal to k1 times t squared over t squared plus k2 to be squared. And you were given a value for k1 and you were given a value for k2, and you were told the initial temperature of the reactor is 24 degrees Celsius. So they want us to find an expression for the temperature. So they want us to finish up with a T equals. So I have dt over dt, big T standing for temperature, little t standing for time. So the first thing I did is I filled in my numbers. I filled in for my K1, 77, and I filled in a half for my K2, and that's to be squared. So if I want to find the temperature, if I want to change dt over dt into time, I need to integrate it. So I'm going to integrate my expression. Now, before I integrate it, I'm going to pop the 77 outside, and then I'm just going to also square my half so it becomes a quarter. Now, we don't have anything in our integral book that looks exactly like that, but we do have a formula that looks a little like what we're seeing here. So we have 1 over x squared plus a squared. So if I want to integrate that, it's equal to 1 over a times the tan inverse of x over a. So if I can make it look a little bit like that, it's going to be much easier for me to integrate it. So doing that is quite tricky. You're going to have to do a little bit of long division. So essentially what I've got is I've got t squared divided by t squared plus a quarter. So I set up my long division here. T squared into t squared goes once, and I multiply back down. 1 times t squared is t squared, and 1 times a quarter is a quarter. Now I want to divide in one more time, so I subtract my bottom line. T squared takes t squared is gone, and I'm subtracting the bottom line, so I'm 0 take a quarter is minus a quarter. So essentially what I want to do now is I want to see how many times t squared a quarter goes into this here, into minus a quarter. Now if I asked you how many times does 3 go into 6, you would just go 6 divided by 3 is 2. And the same thing here, I'm saying how many times does t plus a quarter go into minus a quarter. I'll put it up as minus a quarter divided by t squared plus a quarter. So I'll just rearrange that here, and when I rearrange that, I have my 1 minus, and a quarter divided by t squared plus a quarter is 1 over 4t squared plus 1. So now I can rewrite my integral. So my temperature will be 77 times the integral of 1 minus 1 over 4t squared plus 1 dt. So now I can use my 1 over x squared plus a squared integral. So your x squared is going to be what your variable is here. So here it's 4t squared. So that's 2t all to be squared. That's what my x is there. Okay, 2t all to be squared. And my a squared, that's my a here at the end. So it's plus 1 squared, because 1 squared is 1. So that's what my x value is, that's what my a value is. So plugging those in, that'll be 77 times, now the integral of 1 is just t, and then the integral of this is 1 over a times tan inverse of x over a. Now obviously 1 over 1 is just 1, and 2t over 1 is just 2t. So I'll multiply my 77 in, 77t minus 77 tan inverse of 2t, but don't forget I have a plus c. So if I want to finish off with what they were asking for was an expression for t, I need to figure out what c is. They told me that the initial temperature of the reactor is 24. Anytime you see something like that, it's the initial temperature, that means at the start, and at the start time is 0, the stopwatch hasn't started yet. So I know when time is 0, when my little t is 0, the temperature is 24. So I plug in my zeros for t, and I end up getting c is equal to 24. So now I know that's 24. So just to finish this off, my temperature is t is equal to 77t minus 77 tan inverse of 2t, and plus c is plus 24 at the end.